Have you ever been driving and just wondered what's really holding up the road beneath you? I mean, we're talking about millions of tons of traffic, day in and day out. It seems so simple, right? Just a strip of pavement. But beneath that surface, there's a whole world of incredible engineering. So today, we're going to dive deep into the hidden science of what makes a road truly strong.
So let's just ask it straight up. What is the secret recipe for a strong road? If you had to build one, a road base that could take a beating for decades, what's the one ingredient you'd have to get exactly right? It feels like there should be a simple answer to that, doesn't it?
And, at first glance, there is. The star of the show, the key ingredient, is cement. It's basically the superglue that takes all that loose stuff, like gravel and crushed rock, and binds it all together into one solid, super strong foundation. Easy enough, right? Just add cement, you get a strong road. Well, it's not quite that simple.
Yeah, here's where it gets really interesting. Like with pretty much everything in engineering, the real answer is way more complex. There's no single universal recipe that works for every road on the planet. The secret isn't just what you use, it's all about how much you use. And that number can change like a lot depending on the situation.
This right here, this is a golden rule in engineering. Context is everything. You can't just follow a cookbook. You have to look at the very specific conditions you're working with. So, what kind of conditions are we talking about?
Well, there are a ton of variables. For starters, what kind of material are you using? Is it a finely crushed rock, or is it a more natural, coarse gravel? Even the size of the particles makes a huge difference. And what about the weather? What's the temperature and moisture going to be like while the road base is setting or curing? And hey, how long does this road need to last? 50 years? 100? Every single one of these questions forces an engineer to tweak that recipe.
So, if there's no single answer, where do engineers even start? Well, they don't just guess. They look at data, at guidelines built on decades of past projects. So let's do that. Let's try to crack the code and look at some of this data to find let's call it a ballpark answer for one specific scenario.
Okay, but before we jump into the numbers, we need to know one key term, MPa. That stands for megapascal. Now, don't let the fancy names scare you off. The absolute easiest way to think about it is just as a stiffness score. That's it. The higher the MPa number, the stiffer and stronger the material is. For our little explainer here, let's say our target is a stiffness of 2000 MPa.
All right, now let's look at this chart. This is based on typical Australian engineering guides. You can see it shows engineers the percentage of cement they'll probably need to hit a certain stiffness, but it all depends on the material. And you can see right away how that recipe changes, right? Look at the well-graded crushed rock. It needs less cement, maybe 2.5 to 3.5% to get really stiff. But the fine-grained gravels, they need more, like 4 to 5% to get into a similar range.
Okay, so let's get back to our question. For our example, we're using something called a Class 2 natural gravel. And remember, our target stiffness score is 2000 MPa. So if we look back at that table, we can just zero in on the one row that fits our exact situation.
And boom, there's our answer. For this specific material, aiming for that 2000 megapascal target, you'd probably need a cement content somewhere around 3 to 4% by mass. So we're done, right? Case closed.
Whoa, not so fast. In the real world of engineering, roughly 3 to 4% just doesn't cut it. I mean, we're talking about public safety, about infrastructure that costs billions of dollars. So engineers have to go from that ballpark estimate to, well, bedrock certainty.
That 3 to 4% number? It's a fantastic starting point. It's a really smart, educated guess that gets you in the right zone. But here's the thing. Every single batch of gravel, every quarry it comes from, is going to be just a little bit different. And to build a road that's going to last for decades, you need absolute total precision.
So this is how the pros really do it. They take the actual material from the job site and they take it to the lab. They'll create a bunch of different samples, one with 3% cement, one with 3.5%, another with 4%, and so on. They let them cure under perfect conditions, and then comes the real test, the unconfined compressive strength test, or UCS. It's actually pretty simple. They put the samples in a machine and they crush them until they break, measuring the exact force it takes. That test reveals the precise percentage that works for that specific batch of material.
And that right there is the key takeaway. The ballpark figure is just a good starting point. The lab-confirmed mix, that's the professional guarantee. The ballpark is based on general data. The lab test is based on your specific materials. It's the critical step that turns an educated guess into a scientific certainty. It's how we know the road is safe and actually built to last.
So the next time you're out on the road, remember this. The ground beneath your car wasn't built from some simple recipe.
It was built from a precise, lab-tested prescription tailored specifically for that spot. And that really makes you wonder, doesn't it? What other everyday marvels that we totally take for granted are hiding their own fascinating, complex science?